Hey, welcome back. Good to see you again. Hope you're all well. Thanks for joining the channel. And Merry Christmas to you all. So this is going to be a treat. This is a ROTEL RX-802. And I really like its sleek, low, wide design, even though it's not practical to put on a shelf or put on my bench. It is kind of cool looking, and it's in black. It has a really nice it's actually not black, it's a really dark gray, like a charcoal, anodized aluminum front with black knobs with little bits of silver breaking through to kind of accent it. It looks pretty cool. I like it. So this is brought to me by my client that had the last ROTEL monster receiver, and he wants this one to get the same treatment, get it worked over, and get it sounding good. He says it really doesn't have a problem other than scratchy controls, switches, pots, that kind of thing. And he just wants, the full recap. He wants it all done over, so we can do that for him, no problem. So I haven't ever plugged this in yet, so let's try it right now. Oh, it's nicely backlit. Let me turn this light off. Maybe you can see better. Okay, we got an FM indicator there, a couple tuning. So we are on FM. Switch this around. Here's our AM auxiliary 1. We have a tone. Let's see what we got for this. Controls sound fine. Function switches, everything's good. Some awful noises coming out of my speakers. I don't think that's... Wow. Maybe my speakers are damaged again. Okay, speaker 4 channel. Let's try the FM here. Nothing. Sounds like FM has a problem. Not picking anything up. When I zero in on a station, it just gets crackly and distorted. Let's try a strong station. Back here.
It's a gift card. It's good. Candy canes.
Mix less than 9.
There's a loud hum in the background too. It's like we have a weak power supply. Definitely got problems in the FM tuner for sure. Okay, let's try AM.
People now being eligible for this new program.
AM sounds good.
I know cases of like 4.
Okay, I think I have a good idea what's going on here. The FM needs some help. Now I had a look at the schematic for this, and this thing's just loaded with caps. It's got like coupling caps in all the circuits, and so I have a feeling a lot of those are going to be dead at this point. It's got some cool features. It has separate coaxial bass and treble controls that you can adjust differently for each channel. That's kind of cool. And then it has your coaxial balance back here. It has a faux, this looks like a vinyl wrap, wooden print on it, vinyl wrap. It's in pretty good shape. It does have some scratches on top, but that's expected. And then it's just a matter of cleaning it up. So let's have a look inside. Okay, just before I want to check this here, just curious. This is actually 24 inches wide. You can see that on the left there. That's quite a footprint. Okay, so let's pull the lid off. It's got a wood lid that looks nice inside. No ugly heat stains. So wow, look at this. This thing's really laid out. It's all on one level too, which I kind of like. There's not boards stacked on top of boards. We got our input power here. You know, just unplug this before I poke it. Input power here. Fuse is available from the outside. There's a window here for multi-voltage tapping, but it's blocked off. So this is North American unit. We have two SD370s TO3 devices, so this is quasi-complementary. It's all NPN. So we have a stain here, something spilt. Okay. Power supply with two 6800 microfarad 50 volt caps. And oh, looking at this power supply board, it's been recapped with some Nichicon fine gold on audio caps. Somebody's done some work to this, to the power supply. But the power amplifier has not been touched. It's got the original caps. They look like they're Elnas. Yeah, they're Elnas. They might still be good. Elnas are a very good brand from that time. And then over on this side, tuner front end. This looks like an AM part of the tuner. This here looks like FM. It's a multiplex here. It's got the ceramic filters, and then the IF strip is done with chips, 2 chips, and then we got our multiplex circuit over here. Phono stage here under this cover. And everything else is looking pretty good. We have a light bar here. It looks like it takes the fuse style. Oh, it's got LEDs installed. Okay. So somebody did do some work on this. Got LEDs here. There's an LED on this stereo indicator. Incandescent lamps for the function indicators. Alright, and I believe this has a removable bottom, so I could probably pull the bottom off and get to the boards. Looks like they left a little bit of a mess here. They could have cleaned that up for the lamps. Okay, so we're going to have a few caps change. Going to change all the caps that haven't been changed already. We're going to go through and then we're going to figure out what's wrong with this tuner. Probably just needs a good alignment, unless there's a problem with one of these IF chips. A lot of distortion on the audio, so that could be the multiplex circuit too. It uses a Motorola MC 1310 chip. Okay, it's built well. Constructed well. Got little thermal sensors here on each of these TO3 devices. Okay, I'll get the bottom off. Okay, so here's the bottom. Look at the bottom with the cover off. It's really nicely laid out. Easy service. You have access to both sides of the boards from the top and the bottom. Here's the tone amplifier board. It's nestled in here. And I have access to the bottom of that board from on the other side. Lots of fusing. Count 1, 2, 3, 4, 5, 6 fuses. This one's not even soldered. Look at that. This is just hooked on. Are you kidding me? Is that like that from the factory? It wasn't even soldered. Anyways, problems. There's a couple of resistors here, dropping resistors. I don't know what they're doing with that. Might have something to do with the power supply for this. Yeah, it's this whole back side here is aluminum extrusion heat sink. So it's got a lot of mass, a lot of area, but the fins are going the wrong way. They're all horizontal. They should be vertical, but that doesn't matter much, I guess. Okay, here's the tuner. Got some cobwebs. A little bit of spider action happening. Yeah, so everything's going to be easy, except for the only hard part about this is its form factor. I can't really stand it up on my turntable here because it's so tall and skinny. It'll just fall over, so I might have to, I don't know what I'm going to have to do here. I have to do something. Alright. Oh, where am I going to start? Let's see. Probably start right on this power amplifier and go through. Actually, I want to check this power supply too. I want to make sure everything's good here. These caps aren't secured. They shouldn't be flopping like that because it will break. So I'm going to make sure that's all good. These are only 85 C caps. They are not high temperature caps, so I might yank these and replace them with high temperature caps because it is the power supply and this is pushing out some heat here. That's why these caps failed in the first place, is because of the heat. But putting 85 caps in is not a good plan for a power supply. We can address that. Everything else is pretty easy, so I'm going to get started. I think the first step would be blow this out with some compressed air. It's not bad actually. It looks like somebody's had it open and cleaned it. It's not very dirty at all. Okay, I just started going through here on the power amplifier, changing caps. A lot of these caps have to go. They have ESR 4 or 5 times higher than they should be. They're holding value, but the ESR is a problem. And I'm also finding these carbon comp resistors are way out of whack. They're marked as 10% tolerance, but a lot of these are outside of 10%. So I'm just going to go through and replace them. There's 2, 4, 6, 8 or 10 of those resistors that need to be replaced as well. And then I'll go through and check a few transistors. I don't expect anything was wrong with them, but we're going to check some of these older types just to make sure they're good. So I lift up the power supply board and I already see problems here. I don't know if you can see that too. See that joint here? That's on one of these big unsupported capacitors. They're just flopping in the wind here. The other ones seem okay, but I'm going to yank these caps. These aren't even the right caps for in here. These are 100-volt caps, and they're supposed to be like 63 volts. Let's see here. 63 volts, 1000 microfarad. Okay, 35 volts, 1000 microfarad. 35 volts, 1000 microfarad. They're not supposed to be 100 volt. They're supposed to be 35 volt. And you know, putting that high a voltage cap in there is not doing anybody a good service. But I did finish the power amplifier. That all went well. Replaced, what did I replace? 1, 2, 6 resistors. Those are the ones that were really out of tolerance. The other ones I left alone. Oh, there's some more in here I didn't even see. I'm going to have to check these as well. There's 2 hiding back here. And there's 2 hiding down here. I'll have to check those. Caps are all done. Everything's good. So we'll move on to this thing. Alright, got the speaker relay out. You can see it here. I'm going to check the contact resistance. Place your bets. Place your bets now. Let's go for one channel here. Okay, here we go. Oops. I'm not connecting it to the right thing. Hang on. Let me get my stuff in a bunch here. Okay, here we go. Oops. We got 10 ohms. 22 ohms. Oh boy. Every time it clicks, it's a dice roll. 22.5 ohms. 15. Okay, well, that's telling me all I need to know about that side. Let's try the other side. And here we go. Same thing. 4 ohms, 2 ohms, 2 ohms, 20 ohms, 13. Yeah, this relay desperately needs a clean. Just like every other relay I pull out of a stereo, it needs to have a cleaning. It's pretty basic. You don't need to replace these. People say you have to replace them, but you don't. We've only got... Okay, so I got contacts on both the top and bottom, but I only need to clean the bottom ones, the ones that when the relay pulls in, make contact, and this side here. But I'll clean the whole thing. It's just a matter of bending these up a bit to get a cotton swab inside, and I'll do the polish trick. Okay, here's a look at it after I did the polish the contacts. Let's try it again. Okay, this is one side. We have 9 milliohms. And it's repeatable and consistent. That's what you're looking for. Okay, let's do the other side. Here we go. 8 milliohms. Yeah. It's good to go back into service. So this first switch here is for the dimmer, the lighting. And this fuse that was not soldered, I think it's part of the lamp circuit. These, I think they're polyvinyl chloride. Yeah, PVC. It's decomposing and it's getting really kind of gross. I'm going to take this stuff off and just use some clear heat shrink. Clean this up. They're all like that. They're all weeping that oil, sticky oil. Alright, let's do a little rework here. I've been working on these fuses and they are kind of a pain because they are wrapped. So I'm just going to disconnect one wire. Oh, my wire's turned on? Yeah, it is. Let's give this a little bit of help. Okay. It's the problem with these old electronic, like look at this PVC, it's just turning back to oil. It's kind of degrading and decomposing back into back to its raw materials. Let's try this one more time. Just want to get most of the solder off this lug. Get it nice and hot. There we go. The way these are wrapped is that they bring the wire into the lug and then they wrap it over the top and down. So if you go back here, you should be able to find the end. There it is. That's the wire. I don't want that. Let's separate the two. Let me get more heat. It's kind of fiddly work. There we go. But in the end, you have a nice finished product, you can't really tell it's been worked on. Okay. So this is, there we go. Let's get rid of this. Gross. Yeah, it's nasty. Put a new sleeve on here. Okay. Wrap this around the top and down like the original was. And get this one up and around too. There. And flood it with solder. It's good. Okay, so I got 1, 2, 3, I got 4, 5 done, and I got one more here. And sticky. Okay, I've been testing these two caps here, these main filter caps, and if I check them, let's see here. Let's check this one here. These are 6800 at 50 volt. Okay, and they are. What are they made by? Nippon Chemcon. So they're a good quality cap, but they're also very old. So this one measures at 5200 microfarads. So that's down quite a bit. And this one here is, again, it's 5200 and dropping. Why is it dropping? And you got to remember we have a 5.6K resistor in series with these. In parallel with these, so that would affect the reading. I wonder if I snip that. Let me snip that resistor out of them and see what difference that makes. Let me cut this resistor. So where are we at? We're at 5200 right now. Let's cut this resistor out. And it really didn't go down much. Yeah, it's still good. But I want to replace these caps. Instead of replacing them, what I'm going to do is I'm just going to leave them in place, because when you flip this over, you'll still see the two big cans there. These are the replacements. These are 6800 at 50 volts, exact same rating and voltage. But they are 22 millimeters opposed to, what is this, 40 millimeters, I think? Yeah, 40 millimeters. Quite a huge difference. So I can leave these in place and just disconnect the positive and negative. And what I was thinking of doing is mounting these caps underneath the chassis. There's plenty of room in this chassis. This chassis has about, oh, let's see here, 29 millimeters of space between the plate and the bottom plate. So these will fit no problem. I was thinking of mounting them here like this. Just mount them onto the chassis. I have to relocate this fuse holder and just run my wires, grounds and wires here, and we're done. And then flipping it over, you won't even see the capacitors being replaced, but underneath all the business is being taken care of. So I'll move this. Let's move this fuse holder. I think what I might do, there's about 4 inches of lead on here, so I can pretty much move it anywhere I want. I can move it here, put it on that stud, or maybe I could move it back here somewhere. Drill a hole. Yeah, I might just do that. I'll drill a hole back here and put this fuse back here, way out of the way. And then that opens up this. And I have plenty of room for this. I'll have to bend this out of the way. That fits there. That fits there. And use some adhesive, glue those down. And that should work. So let me get busy on that. So I was relocating this fuse, and I was looking at it. What is it for? And because it has all these fuses, it's got 7 fuses in it. And I look on the schematic, and there's only like 1. But if you follow the wires to this fuse, it's in series with this fuse. So this is a 3.5 amp fuse. This is a 3.5 amp fuse. So guess what? If you blow a fuse and you put a 7 amp in here to try and thwart it, this one's going to go next. So it's a little safety thing, I think. Okay, here it is. It's not the prettiest thing, but it's going to work. So I completely removed the wires from the original capacitors, the power and the ground. And I'm reusing the ground on this set. Now this is my negative capacitor, this one's my positive. And I really should rework. I'm going to reroute these 2 red wires up above here so that it doesn't really matter. So they're all connected. Now one thing I did, they had a 5.6K resistor here, bleed resistor on both capacitors. Some stereos have bleed resistors, some don't. I have a feeling they're a good idea because what it does when you shut the thing off, it bleeds down these capacitors to 0. And you know, if you didn't have bleed resistors, I think you might get one capacitor that stays at like 11 or 12 volts, and then one that goes down to 0, and then they won't be equal. When you power it back up again, the current won't be equal. Not that it matters, but it might make noises when you start up. So well, this one won't because it has a relay. But so what I did, instead of 5.6K, I figured that was a little too low. What I did is I raised them up to 10K. So I put 10K dropping resistors on these. The reason being, 5.6K will consume about 360 milliwatts. So 360, so that's what, 720 milliwatts, 720. And these will consume about 200 milliwatts each. So that's down to 400. So it's a little bit of power savings, no big deal. One thing I have to do now is anchor these caps because they are just floating here and there's no anchor whatsoever. So I'm going to give it a liberal amount of this stuff. Let me see here if I can get this squirted out. And once this sets up, this cap won't be going anywhere. So that's good enough for that one. And we'll do this one. Of course, you want to make sure that there's nothing poking the jacket of the capacitor because it's just a thin plastic. Okay, so those 2, once that sets up, that'll be ideal. We have plenty of room. There's nothing that's going to interfere with the covers, so I'll just let those set up. And I think I might cut that tie, remove these 2 red wires over here. I could have even shortened them. Doesn't matter. I could just leave it the same. It's kind of a mess here, but whatever. These are all ground wires. That and that will set up. Okay, I'll let that set. Okay, that now leaves me at a point where everything's done, except I need to clean this board. And I haven't done anything to the switches or pots because when I did my initial test, they were fine. And it looks like somebody's already embalmed all these switches with deoxit. So they have that oily film on them, and they're working fine, so I'm not going to touch them. Usually if a pot or switch is working fine, I don't like messing around with it. This switch here had a broken piece on it, and somebody used a chunk of wire and drilled a hole and glued it, which is fine. I'm just wondering, maybe I should just replace that switch because that button can get lost really easy. It just all the deoxit and oil and everything is just kind of, the adhesives aren't holding anymore. And it's a simple switch. It's like a dual pole double throw, and that would be an easy fix. I'd have to pull the board out again. No, I wouldn't. Yeah, I would actually, because it's on the 4 switches are connected together on a rack. When you think about that, this button here, You can't see it because it's out of frame. Let me see. This button here is a chrome button, and it's out of place, like somebody replaced it. I don't know if they replaced the switch. I don't think so. No, the switch hasn't been replaced, but the button end cap has. It probably should be black. I'll see. I'll dig through my stuff and see if I have a black aluminum cap, like looks like these. I don't think I do, but actually I didn't even notice it until after I had this thing apart and I was looking at it. But this one here, I'd definitely like to fix this. Maybe I should do something with that. Once the faceplate's on, it won't really. It should be okay. Yeah, I'll change it. I have to dig out that stuff though. You know what? If I dig that out, I might damage it, so maybe I'll just leave it alone. It's working, and it looks okay. So the rest of these are okay. Pots and switches I'm not touching. Fuses are all finished putting in jackets, new jackets on those. Finished the caps. Got to clean this board. These two are clean. And then I can get on to testing. Alright, so I moved the fuse holder from back here, where this cap is now, around to here. And it's sitting on this little ledge here. It's a little about 1/4 inch higher than it normally should be, which is kind of opens up a dangerous situation here. It was a little too close to the bottom plate, and if there's if I put the plate on the bottom cover, you can see there's actually a foot right here. Now, if for whatever reason, if this thing gets loaded with a lot of weight or something drops on it or whatever, and this bottom plate gets bent and pushed in, it could make contact with that mains fuse, because it was only about 2 or 3 millimeters below the plate, right? So you can see right here on the transformer where it's been making contact with the bottom cover, which kind of protects it, but not totally. So what I did is I just got some insulating sleeve. This is some what do you call it? It's called just insulation. That's all it is, sheet insulation. And I glued a chunk on right where the fuse is, so that if this foot ever does get crushed in, it won't make contact and electrocute the owner. So just wanted to make sure that that was taken care of, because that could be a potential for a serious shock hazard. Okay, I'm going to put the bottom on, just temporary, because I want to flip this over, and we want to do power test, and then we're going to address everything on that tuner that's wrong. Okay, let's get this show on the road here. We got wired in for a power test. Let's plug it in, and let's see what it's going to do. Is it going to fly or fry? Okay. Let's see. Scope's hooked up. Voltmeter's hooked up. Oh, we need tones. Okay, hang on. Get a tone set up here. Alright, now we got tones. 1000 hertz. Okay, we are on speaker system 1. Let's turn it on. Relay clicked. We're at 26 watts. 24. Pretty good. Let's hear a tone. Little channels. Balance. Left, right. Okay. Treble. Bass. Everything's working. Dimmer. Can't really notice much difference. You know what I might do? I might change some resistor values in here. Make it go a little dimmer than what it is. Anyways, let's get rid of this tone. Let's go to channel 2 for our speakers. Let's turn up the volume. Let's set up the scope better than this. Okay, here we go. Keep taking it up. There's clipping. And back it off a bit. Right about there. And we have 20.06 volts. No, sorry, 21.06 volts RMS on the output. It's doing pretty good. Consuming 220 watts on the outlet. I'll let this cook for a while. Starting to hear whine coming out of the it was silent up until about the 8-minute mark here, and then it started making a whining noise. This heatsink is barely warm. I don't feel the heat on this heatsink. It's just warm to the touch. And it's been going for over 8 minutes now. That's putting out a lot of heat, my load. We're still drawing 218, 219 watts. Might be just a transformer winding. Okay, we're at the 10-minute mark, and it's been doing everything I wanted it to do. Heatsink is not very hot. It's actually barely warm. Even the drivers, I can put my fingers on them after 10 minutes at full power. Even the drivers don't burn my fingers. So I have a feeling this thing is very capable. So what I'm going to do now, let's check some, let's see here, let's go down in signal strength. Let's check some square waves. Turn down my probes. Turn this back up. Okay. Alright. Okay, so that's 1000 hertz tone. I don't know if I have my... Okay, yes, treble cut, treble boost, let's null that out, bass cut, bass boost, pretty good. Here's the balance, pots are nice and clean, volume control. Now remember, I didn't touch any of these controls with any cleaners or anything, I just left them alone. So far so good. So let's turn this up. Frequency. It's 5 kilohertz. Not the greatest. 6, 7, 8, 9, 10. So it's not really the fastest amplifier on the planet, that's for sure. Let's keep going. 11, 12, 13, 14, 15. There's 20. Pretty much lost our square wave altogether. There's quite a bit of rise and fall time there, so. Alright, let's shut this down. Next I want to go after the FM tuner. I want to see what's going on with that. We could actually try it out right now since everything's hooked up. So let me get this reconfigured and we'll set this up.
next week, but we didn't.
The family, and that's why we added a third light.
Collaborer non-stop avec plein de monde.
En essayant de se réinventer.
So the tuner's actually working a lot better now. It's not all distortion like it was. I have a feeling it still needs tune-up though.
Music that announced.
I'm not getting any stereo indication here.
Bank. Regrettably, food banks have never.
Still not getting stereo. I wonder if that's my settings. Muting FM audio. It's FM muting. Should pick up. Okay, now I just heard stereo separation, but we don't have no light. So what's going on here with that? Yeah, I broke a wire maybe. It is not wired very well. For whatever reason, that is not lighting.
Still looking for the right gift? Visit us in store or online starting Saturday, December 16th. And wrap up the year on a good note. Princess Auto. Ideas. Tools. Drive into the holidays with some sweet savings across Mitsubishi. Right now, get 2.9% on select 2024.
Yeah, I'm getting no stereo light. So, FM tuner's working. It does need a tune-up. You can tell. It just sounds a little harsh. I'm going to go through AM, FM alignment, and I'm going to figure out why this stereo light is not working. Alright, looks like we're getting close to the end. It's been turned on for about an hour now, and this heatsink's getting quite hot. And I think I'm still on tuner. I think that's probably the reason why it's so warm. But let's just see here. It's up around 50 degrees. 51, 53. So I'm thinking what I'm going to do is add a heatsink. Use something like this. Cut this in half and then add the top, or just to the top. I don't want to muck around with the screw. Or could cut about 2 centimeters off of this one and put that one on. I have to cut the ears off. That would be better, I think. And that'll really drop the heat. I think I'll do it with the black. Okay, I think that'll be just cut just the right size. Probably what I'll do is I'll drill through holes, these 3 M3 self-tappers, and clamp those 2 together with some compound. Okay, one thing I want to do here is set the bias on these amplifiers. So on the instructions it says between pin 15 and test point. So that's this one and this one, both on side of this big capacitor. And then pin 16 and test point for the other channel. I don't think it's marked test point. Yeah, it is, but you can't read it because it's covered up. So let's connect up our meter. And what the spec is, I think it's, let's read it again, I think it's 30 millivolts. You have to be careful, there's 120 volts here in the corner by those courtesy outlets. So let's just connect this one here. And we got 11. And the spec is, what is the spec? Right up on the screen here, but I can't read it. 30 millivolts, okay. So, currently we're at consuming about 25 watts here. You can't see the meter, it's out of the frame. Let's turn this up to 30 millivolts. And there's no way we're going to get 30 millivolts out of this. Let's see, we might have to treat this pot. Well, there's 28. But we're right at the end of the adjustment. So what does that tell me? Let's try the other channel first. We might have a problem in this channel. Let's go over here. Let's see here. Okay, 8.5. And this one's maxed out too. This is not. I can take it up to about 20 millivolts, and then I'm at the end of the range, and then it drops back down to 0. That's not cool. And both amplifiers are like that, so maybe these trim pots are bad. Let me get my what are these trim pots supposed to be? 5K. All right, 5K. I hope it's not the stabilizers are damaged. We got 5K and we're out of range. So something's wrong with the circuit. I'm going to measure the voltage across those stabilizers, and we should have 2 diode drops. So let's do that. Let's go over here. Where is this one? Right here. And we got 1.17. That looks normal. That's okay. Let's try the other channel. .10. That looks normal. Let me kill the power here. I'm going to check these 2 trim pots. I have a feeling they're fine, but for whatever reason we ran out of adjustment range. It was up to 12, 13, 14. It's up to 20. Oh, here we go, 25. Let me treat these. I'm just going to treat them with some F100. And a very small. Oh, I can't treat them because they're upside down. Okay. I might have to pull those trim pots and clean them because they are not acting properly. Can go up, up, up until we get to fully clockwise, and then it drops back down. See, it keeps going up. Keeps going up until I get close to fully clockwise, and then it opens up. Okay. Okay, got my ohm meter here. Let's zero this. And it looks like we're zeroed already. Okay. Okay, we're zeroed. Let's try this one. So it was fully, which I can't remember now, fully clockwise or fully counterclockwise. Let's get this. We got to set halfway. Set halfway, we're at 3K, a little less than 3K. So let's try this. Let's go counterclockwise. And it goes to about 5.5K. looks like. Oh, there's a little bit of a spot there where it's, see right here? There's a little bit high resistance on the carbon track. So let's see on the other end. The other end is a little flat there too. Let's try the other pot. Probably just going to end up replacing these anyway. I don't think they're... I could clean them. Alright. Counterclockwise first. So there's an open spot right here. Okay. Let's go the other way. Oh, there's a little bit of open spot there. You can see it's twitching as I go past it. I'll go slower. There, right there. Okay, I'm just going to change these pots. They're 5K. Alright, we got 2 new trim pots in there, so let's try this again. Let's see how our adjustment range looks. We're down to 1/3 of a millivolt. That's not cool. Alright, let's see if this goes up or down or what. Going up. I don't think they should have put a 5K pot in there. I think it's got way too much adjustment range for what it needs. What did we want again? We wanted stupid 30 millivolts. I don't know if we'll get 30 millivolts out of this. The speakers, everything's disconnected. This turned down. Yeah. $13, $15, we're getting there slowly. Might run out of adjustment range here. $20. It's very touchy at the end. Let's leave it at 28. No, that's as far as it goes, 27. Look at that. That's weird. $5, $26. Come on. It's as high as I can get it. Let's try the other one. We might need to make some adjustments to the circuit. Alright. 23. Is that as high as it goes? Is it as high as it goes? It's 23. And then it drops off. 22. Got to be something wrong with that circuit. I'm going to peak these out to maximum current, and then I'm going to remove them and measure them and see what they measure out of circuit. I mean, they're probably right at the end of their adjustment range. $22. $33. Still going. Very, very touchy. And it drops. Okay, 24 is our max. Back this off again. Okay. Alright, I'm going to have to look at the schematic and see what I can do about that. We're not getting enough bias current. Okay, let's measure these trim pots. I didn't touch the adjustment, I just left them in. We're unplugged now, so we're okay. So this one here measures 137. This one here measures 137. So I'm going to take these 5K trim pots out and put in a 1K, and that'll get us a range between 1000 and 0 ohms better. And I don't know why they specified a 5K pot on this, if it's going to be all the way to one end of the adjustment. And I noticed that on the original trim pots, they were all cranked one way to the max. And just looking at the schematic here, and there's no other reason why a 1K won't work. So I'll do that right now. Change those two pots out. So you yank the two transistors out. These are the bias spreaders, and they're 2SC1384s. Now these are Q, HFE class Q, and I tested these on the tester, and one of them came back at 95 HFE, the other one came back at 100, which seems kind of low to me. But then I looked at the data sheet. The data sheet says for ranking Q it's 85 to 170, so it's still within the spec here. I've tested other ones. This one's an R ranked, and it comes back at around 175. But this is a brand new transistor. I think these transistors are okay. I'm going to put them back in, and I'm going to I've switched the trim pots from 5K to 1K. That should buy me some more adjustment range to get this to work. So let me try it out. Okay, we're back with some new 1K trimmers in there installed. Let's turn this on. Alright. Can you see the meter? Not really, eh? Bloody glare. There we go. Alright, let's see what we get. Should get up to our spec of 30. Yeah, I put those transistors back in. I think they're fine. I don't see any reason to change them. Closer. It dropped to 19 again. What the hell? 22. Then it starts going down. These trim pots are not the greatest. We don't have enough adjustment range still. Okay, it's maxed out there. I'm going to measure what the trim pot says. Let's try this one. We might have to change those transistors after all if we can't get enough range. Put a higher gain transistor in. Okay, let's try this one. Where are we at here? 11. $21, 22, 23. I'm wondering if I'm getting to a point where there's too much current for the trim pot and then it just kind of goes open circuit. 25. 26. We're still going. We'll leave it at 28. You can't get 28. See, it won't go that high. It goes to 27.4, and that's about it. Alright, so I was busy the last couple of days. I had visitors and had other things to attend to. So I put this aside for a while, which is good because it gave me time to think about it. Now, I thought about these trim pots that I was using. It seemed like they couldn't deliver enough voltage or current or whatever. I was thinking about the data sheet. So I pulled the data sheet for these, and they're good for contact. Where is it? Limit current of moving contact is 100 milliamps. Rated power at 315 volts max is half a watt at 70 degrees C, 0 watts at 125 C. So I think these are capable. I just don't understand why they're not going. So another thing I did is I pulled the two transistors, these 2SC 1384s, and tested from beta. One tested at 90, the other tested at 100. And I was thinking, you know, that sounds a little low. So I pulled out some of my other 1384s and tested them. They had the same range. But these are the lowest HFE rank that you can get for this transistor. This is a Q rank. So I decided to up it, and I installed the next rank up, and these are the same transistor, but they're a little higher gain. These are about 174 or so for the both of them. So I put those in, and I opted to retry the original pots. I cleaned them up with deoxit, and I reinstalled them. We're going to go try with these one more time, because if this changes the range of this will work. Another thing I did is I installed a heatsink on the power supply board. This was getting a little too hot for my liking, close to 60 degrees C. And when I took the aluminum off the printed circuit board, I could see a big burn mark etched into the printed circuit board. So this thing does get really quite hot, and it'll be a lot cooler now. I'm expecting it's going to be about 45 degrees, maybe at the max. So what I want to do is connect up a biasing meter. Let's go with millivolts, and we'll try this channel first. We'll turn it on and see what kind of current we get, or if we can even reach our set point. Okay, so that's plugged in. Let's turn it on, and here we go. Okay, so we have very, very few millivolts. And it doesn't seem like we got any change here. It's the same. So I can reach about 17, 18. we're no better off than we were before. Okay, on this biasing circuit, according to the service manual, I should be able to get 30 millivolts across one of these emitter resistors by adjusting this potentiometer or this one, and I can't do it. I can get it up to about 24 millivolts here by cranking this all the way to the one side, but if I go beyond that, it collapses and the bias current drops. And I don't think it's a problem with any of these components. I've yanked out all these transistors and tested them on my tester and my curve tracer, and they're all good. I thought at first these were low gain, but then looking at the HFE ranking, they're right within their spec. And I even replaced these two transistors with a higher gain version, and it made no difference whatsoever. Measuring voltage across these stabilizers, everything looks normal. I get about 1.1 volts, and if I crank up the current by lowering this resistance, it goes up to about 1.3 or 1.35. That's where it maxes out. Now I noticed that I connected a voltmeter across the stabilizers, and as I adjust this resistance down to increase the current through it, the current climbs up through this, or the voltage climbs up as the current goes up. And then as I hit that point where I get maximum biasing current, if I keep going, this current increases, but the current collapses here, and I don't understand what's going on. I measured this 4.7K resistor. I measured the voltage across it, and I'm getting about 6 milliamps of current through this string. And I confirmed that by measuring this 68 ohm resistor, and I'm still getting 68, or sorry, did I say 6? Yeah, 6 milliamps through this as well. So it's through this transistor, through this potentiometer, through this stabilizer, through these two resistors. So no matter how I adjust this, I can't reach 30 on here. So what I've opted to do, I'm beginning to think it's a mistake. I'm beginning to think 30 seems awfully high. Well, could 0.47, that's almost half an ohm. 30, what is 30 millivolts across half an ohm? Okay, I equals E over R, so 30 millivolts divided by 0.47, and that gives me 63 milliamps, 64 milliamps idling current. I think that's too high. I would like to see that half of that. So what I propose to do is I'm adjusting these two trim pots to provide about 12 to 15 milliamps of idle current, and I'm going to leave it there. And that's with all the original parts put back in, because I see no reason to put these new parts in. Tested the stabilizers, they both test equal and good. These transistors, everything's fine. I've put new resistors in because they've drifted. I can show you here. I replaced these two 4.7Ks, and I replaced these 2.2Ks because these are the ones that were on this divider network here. And these have drifted quite a bit, these two resistors. These four resistors actually, they drifted quite a bit, and I replaced them. So they're on spec now. But as I noticed, I returned these amplifiers both to about 15 millivolts idling current, and the trim pots are back to the original positions where I had them when I first started. So I'm going to leave it as is. I'm going with this 15 millivolts, and somebody correct me if I'm wrong. If there's something I'm missing here, please point it out to me, because I've been through this whole circuit and I can't seem to pinpoint what's going on. But it works fine. You saw on the power test that we're getting good power, or amplifier is working fine. Okay, I'm trying to figure out this stereo lamp on the FM tuner, and I just discovered another problem. Look at this post that's on this printed circuit board. You can see it's either detached from the foil or something's wrong there. So what I was doing is hooking a voltmeter across the LED bulb, just trying to get a reading on if the lamp should be on or off. And I got what I got here. Let me zoom out. If I wiggle it just so, get 17.8 volts. And as I do that, the lamp comes on. Look at this. So I don't know if you can see the lamp. See the lamp there is flashing. I gotta fix this joint. Yeah, and sure enough, you can see this on the other side here. This is, the pad is completely torn away from the trace. So I'll just run a little jumper, and that can flop in the wind all at once. I don't care, as long as it's connected. So it comes straight out of the chip, eh? The lamp. Okay, fix that up. Result. So it's been fixed, and we have our stereo lamp back. It's nice to know. Okay, I'm going to run through. I'm going to reinstall the dial face, the dial scale, and I'm going to run through an alignment. I'm not going to show any of it. I'm just going to go through and check the AM, FM. I have a feeling there's probably something going on. Maybe it's just interference noise, I guess. Let me see here. I'll shut off my... And that kind of stops. It wants to... Yeah, good for a tune-up. Okay, gone through and did AM, FM alignment. The AM alignment went really well. Got lots of gains out of that one. And the FM actually improved the sensitivity and brought it in quite a bit. The tuning dial was off. A few other things that were off. The dial accuracy was way off. It was about 0.5 megahertz off. So that's all been adjusted now and put back to right. So let's go through and let's listen to some local stations. See, I'm getting this interference. I get that on all the... I don't know what it is. Something around here that is doing it, and I have everything shut off. But anyways, let's...
La toile de fond, elle est magnifique. Moi, c'est l'intrigue. Là. Il me fallait quelque chose. Peut-être que je regarde trop.
So, this station's always in mono for some reason. Maybe my tuning meter's off still. I'd have to adjust that. No, actually that's correct. The signal meter is working. The center station is working. Putting in some pretty weak signals here. I just have a wire connected, and actually it fell down too, so let me put that back up.
Kissin' Country 103.9, Edmonton's official Christmas day. Almost down to Amber.
Tuner's working a lot better now than when I first started. It wasn't even picking anything up, so it's pleased with that. I'm really happy with the looks of this thing. It looks pretty, I think it looks pretty cool. It's not really black, it's more of a charcoal color. And it's faded somewhat too, because when you pull off the knobs you can see where the knob was, and it's there's a dark spot here, and everything else around it's been faded. Looks like it's been faded by the UV light. But pretty happy with the results of this. A lot of work went into it. I wasn't happy with the biasing though. I don't think that was right. That was in the manual. I could be wrong, but I don't know. So here's all the capacitors that went in. These 5 big ones, they were replaced because they were totally the incorrect value, or not value, but voltage. They put 100 volt caps in where they needed 35s. That doesn't sit well with me. Half a dozen resistors, and the rest of all the caps are gone. Elna caps. Yeah, so it's ready to go. This will get returned to the client after I listen to it for a couple weeks. So it's gonna sound good. I have a feeling it's gonna sound good. Alright, that's it for this one. Thanks for watching. I'm gonna wrap this up. I'm gonna test drive this for a few weeks, get some nice listening time in with it, and before I return it back to the owner, and I'm sure he'll be pleased. I hope he's pleased with it. Had a few issues, but we cleaned them up. So that's it. Take care, and I wish you all a Merry Christmas and Happy New Year, and we'll look forward to 2024. It's going to be a good year. 23 wasn't bad, but 24 will be better. So take care. See you later. Hi, it's me again. So I was doing the editing for this video, and I was thinking about it at the end when I finished. What I did is I went on to search engine and I searched for, what did I search for? RX-802 bias. That's what I searched for, and bang, up popped a form, a thread on a forum in the Audio Karma forum about this receiver and the bias problem that I was having. Exact word for word, step for step, same thing I was having troubles with setting the bias. And another from 2008, another forum user had the same problems. And there was a very good answer from another member in there. I can't remember the name. I should go look it up and post it. I'll put a on the bottom of the screen here. The credit goes to him for it, but he laid out a very detailed explanation of why this happens, what the problem is with the bias circuit. Basically, it boils down to poor design. That's what it is. And he lays that out on what it's doing wrong, and he offers a suggestion on how to fix it. And very good explanation, very detailed and in-depth. And I wanted to put this segment on the end of the video just for anybody in case they have one of these receivers and they're having trouble setting the bias. I just wanted to kind of follow up and give them the information that if you go to and do a search for RX-802 bias, it'll pop up and you'll see what I'm talking about. Now, he suggested making some changes to the circuit, which is removing one of the transistors and replacing it with a fixed resistor. I opted not to do that. I'm just going to leave it the way I left it. I'm going to have the bias set low, and I'm just going to leave it like that. I'm happy with that the way it is, without making any modifications. But the information's there if you need it. So I just wanted to add that. So yeah, hope that finishes up and clears up any questions some of you might have had. So I'm going to wrap this up so I can get it uploaded and ready for tonight's release. And then hope you guys have a great Christmas and happy holiday season. Talk to you guys later. Take care.